do Wednesday. I think I'm all caught Friday. I think I'm all caught up with returning all the grades. Not so much with my emails. I'm under 200, which is a good thing. If you actually want to respond in some reasonable amount of time, then email cs101 at cs because that's actually checked by somebody who's much better at responding to emails than I am. And of course, we have a midterm next next Wednesday in class. We're going to have a review on Monday, and of course, a lab quiz after that. Other than the fact that it was really chaotic because I was slightly distracted, any questions, comments, or concerns? Okay, so I talked to the people from the clicker company, and they've told me that things are going to suddenly start working. It's above 0. That's amazing. So, 20% is like, really? You have class on Fridays? I have considered, so I'm loath to cancel classes, although I must say I'm all for like university canceling classes. So this morning I was really hoping that like all classes would be canceled. No, it wasn't the case. Then I'm like, wait a minute, I can cancel class, but then I feel guilty that I canceled class and missed the opportunity to have you guys trek through the snow to be here today. I'm still sort of debating whether or not to have class the day before spring break, because although I'm loath to cancel classes, let's face it, if like 10 people are going to show up, then it might not be the most worthwhile thing. So I'm thinking that currently that's saying we'll ignore the people who didn't realize this Monday, Wednesday, Friday class for a moment or two, and say maybe about only half of the class is going to show up on Friday. I don't know, I'll still debate about it, but it's a possibility since I don't think many people are going to be here. Okay. Actually, when the gentleman was here at first, I've had people come and ask if they could give announcements in class, and I always tell them to come back later. Actually, I tell them they have to let me know ahead of time. So I thought he was here trying to give an announcement, and that's all ready to be like, you can't do that! And it wasn't. Okay, so we had talked about if and if else. And blah, 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 blah. One thing, actually I want to go back a slide just to show one particular thing. Right. Where am I going with this? So we have talked about how on a given if statement, it will either execute the next single statement, like when you have an if, it'll either execute the next single statement, or it will execute a series of statements surrounded by braces. We have the pretty little curly braces there, and the pretty little curly braces there. And we've seen a couple examples of this, right? In this particular one, we have an if clause, and we have an else clause, right? And this, whatever is between that brace and that brace is executed on the if, and between that and that is executed on the else. So, all right, we've seen all this before, right? Our pretty little flow charts that we love so much. This was the last slide we talked about. Turns out, so this is the first new slide. That was just, I wanted to remind you all about the brace issue. Turns out there's many different ways that people like to have their braces. And there are whole, literally, people will go on the internet and start arguing about this stuff. So this is certainly one way to go about doing it. This is where every brace starts at the left column, and except for the brace after the else. Or you could do it this way. You notice the difference is which brace the else is with. This is actually called cuddling the brace. I kid you not, that's a real term for it, because the else cuddles that particular brace. Here, everything's on its own line. Here, the if cuddles the brace and the else cuddles the brace. or that's probably the most compact form. I don't care how you do your braces. Personally, I do it this way just because it's the most compact. The reason I point this out is however you do decide to do your braces, pick a way that you like, that you feel is most appropriate to your personality, whatever that might be, and stick with it. So you can do it any way you want as long as you're consistent. There are a lot of people who like it this way because here the closed brace and the open brace is on the same line. This way here, the closed brace and the thing that opens it, in this case the else, is on the same line. Again, it doesn't really matter so much as long as you know there's many different ways to do it. Pick a way you like and run with it. So let's say we have a statement such as this. So if number is not equal to 0, then if number is greater than 0, print out positive, else print out negative. And the question is, that else could apply to either one of the ifs. And Java, as it's sitting through and compiling your program, has to sit there and has to figure out which one it applies to. And this is and the particular way that Java does it is the else will always match the most recent if that doesn't have an else. Meaning this else here, how about red because it's Valentine's Day? That else there will match that if because that's the most recent if that doesn't already have an else. If I had an else here, then that would match the most recent if without an else, which is that one. So you can see what it looks like when we don't actually have any white space. And then it starts becoming even more confusing what's going on. We like to indent things quite a bit, so this whole thing should be indented a bit over, et cetera, et cetera. Remember that the whole purpose of white space is for a human to figure out what's going on. Java couldn't care less if there's white space or not there. But a human needs to be able to read it. Whether it's you trying to figure out your code or a grader trying to grade your code, ultimately some human is going to have to read this. That's why we like the white space. Okay. Right, and that's just an example showing that last slide, both with nice proper white spacing. And you see that it makes sense what's going on. If number is not equal to 0, all of this is going to be executed. And if number is equal to 0, that's going to be executed. If I could highlight it. So that's why we like white space. Okay. So there's two main professional organizations for computer science. One is the ACM, which is Association of Computing Machinery, and the other is IEEE. And IEEE is Institute of Electrical and Electronic Engineers. And they were started a long, long time ago with, they focus a lot on electrical engineering. And since computer science was largely an outgrowth of electrical engineering, they're one of the professional organizations for that as well. Conferences are sponsored by one or the two of those. And when you are writing articles for a journal, now, or a conference, most conferences, again, are either IEEE or ACM, there's often a contest by the authors, I'm quite serious by this, to try to make the article as difficult to understand as possible. And I've seen these, so I've done a bunch of article reviewing, I've seen these articles that have really like no substance to it, but they do all these really complicated formulas and equations to try to make it look like they have something there when really they don't. So it came out with this, this is partly a hoax, but partly it's kind of true, which is why at least I think it's really funny. So let's say you wanted to publish something as simple as 1 + 1 = 2. And that, if you're publishing on that, that's kind of obvious. So they have ways to obfuscate it or to make it more technical. And for example, 1 is the natural log of e, and 1 is also equal to sine squared plus cosine squared. And 2, of course, is equal to that summation. So then you can more scientifically rewrite 1 + 1 = 2 as something like this. But why stop there? It turns out that 1 is equal to the hyperbolic cosine of y times that square root thingy, and e is equal to that limit. And what you can do is you can take 1 + 1 = 2, replace it with, so we have this so far, we're going to replace the e with that limit, and that one with that, and we get this whole great formula. It basically says 1 plus 1 equals 2. And I say it to you in sort of tongue-in-cheek, keeping in mind that there are a lot of articles that will actually have that. And they also try to use really highfalutin words, which makes it very unclear what's going on. But if you look at like the word length, it's really long words. They must have an idea what they're talking about. Yeah. So if you start publishing too, you can start using these techniques to gain more and more paper acceptances. Or maybe I'm just cynical. Okay, we've seen 2 of the 4 types of decisions. If else, and next up is if else if. So let's look at this code. If number is equal to 0, print out 0. Otherwise, so this whole block, of course, is done if, I had a felt tip pen, that whole block is done if the number is not equal to 0. And then, of course, this number is greater than 0, print out positive, else print out negative. So for some integer variable called number, we're going to print out 0, positive, or negative. And of course, what we have here, we want bread today. What we have here is that within this block, we can have as many code parts as we want. We just have a single statement, which is this if-else clause. So it turns out that these 2 braces are not needed. Java knows that when it hits this else, it's going to apply to the most recent if. So we don't actually need those particular braces. We certainly can have them if we want, but we don't need them. So we're going to remove those. And this still does the exact same thing as before. We can get rid of whatever white space we want to get rid of. And in particular, what I'm going to do is I'm going to move this to the previous line. You like these PowerPoint animations? And I'm going to slide that over. Okay, you want to see that again? It took me hours. Ooh. Well, I joke about it. The point is that this code here is exactly, will perform the exact same function as the code before, but it's a bit easier to read. If number is 0, print out 0. Else if number is greater than 0, print out positive. Else, print out negative. So this is the if-else if. It's a series of if-else's put together in such a way that we have an if, else if, etc., etc. This if-else if, one second. This if-else if is going to be a key component of your homework next, whatever number is after the pirate homework. We're going to be using this. Question?
So this can become like a tree of else's and ifs?
Yes, and in fact, the 2 slides I'm going to show an example about that. The question was, can this become sort of a long cascade of if-else ifs? And yeah, we're going to see that in a moment. So let's say we had 3 integer variables, n1, n2, and n3. We've seen how to sort 2 integer variables. Now we want to sort 3 integer variables. There's a total of 6 possibilities as to which is the highest, which is in the middle, and which is the lowest. Right? Those are the 6 possibilities. So what we're going to do is we're going to have the original values in n1, n2, and n3. And we're going to have the sorted values in s1, s2, and s3. S for sorted. And here we have our if-else if. In particular, what this says is if n1 is less than or equal to n2, and n2 is less than or equal to n3. So if it's one particular order, where it's n1, n2, n3, I'm going to assign my s's appropriately. Else if it's n1, n3, n2, I assign my s's appropriately. Else if, else if, else if. Eventually, I hit the else, and that's going to only apply to the one remaining case. So here we have a, well, you said tree, but like a list or a cascade of if-else ifs. And this is, I would argue, a bit easier to read than if we had it sort of each one indented a bit. How many people feel they understand this slide? Okay, I'm seeing not all hands. How many people feel they're a little confused on the slide? Okay, I'm seeing some hands, so I want to spend some time. Okay. As essentially what this is doing is going through going through each of the 6 possibilities in order, right? So we have the 3 values, n1, n2, and n3. There's some variables, they have some values, I don't know, 7, 10, 15, whatever you want. But we don't know which one has which. And there's a total of 6 possibilities as to which is the lowest, which is in the middle, and which is the highest. And what we want to do is we want to figure out what order they're in, and put them into S1, S2, and S3, such that S1 is the lowest, S2 is the middle one, and S3 is the highest. So what we're going to do is we're going to go through each of these 6 possibilities, and for each of those 6 possibilities, we're going to assign S1, S2, and S3 appropriately. So this first if part here, if it's the case that n1 is the smallest, or n1 is less than n2, and n2 is less than or equal to n3, meaning n1 is the smallest, n2 is the middle, and n3 is the highest, I'm going to assign them as such. S1 is the lowest, S2 is the middle, S3 is the highest. I'm kind of ignoring when they're equal here. So that's one of the 6 possibilities. The next thing here, this cell says otherwise, meaning if this first possibility wasn't the case, this evaluated to false, it's going to see if this possibility is now the case. Meaning, is the current order they're in n1, n3, n2? If so, assign them appropriately. Otherwise, so if both of these were false, it's going to check to see if this is the case. If that is the case, it's going to assign S1, S2, and S3 appropriately. Give me 2 seconds. And et cetera. So it's going to try each of these cases until it finds one that it does satisfy. And one of these eventually will be found. If none of these work, of course, then this else will be found. And it will assign them appropriately. Question?
So the point of this is to not get a numerical value, but to get which one is the smallest middle one.
Yes.
That's what
Yeah. We'll assume that they've already been read into N1, N2, and N3. So the point of this is to be able to put them in some sort of order. So S1 is the smallest of those, S2 is the middle of those, S3 is the largest of those. We don't know which of N1, N2, and N3 are the smallest, middle, and largest. Obviously, if you're starting to sort 4, it becomes a lot more difficult, and there's very different means of sorting when you have like 4 or 5 or 100. We're going to see those a bit later in the semester.
What happens? Will you ever have a case and would make it all be false? I mean, if that's the case, will it return like a null or something like that, or negative 1 to say there's a?
The question is, what happens if they're all false? So there's a couple ways to answer that. In this particular slide, because this last one just says else, it could have said else if. But because the last one says else, if these first 5 are false, then it will execute that. But if we were to take off this else and completely remove that, so now the last clause is an else if, it is possible that all of those are false, right? Because certainly there's only 6 possibilities, right? So if it's the 6th possibility that's not listed now, and I've scribbled out some of that code, it's possible that one of those is, that it won't execute any of these bodies, at which point it just leaves S1, S2, and S3 unassigned. It will execute one of these, it will execute only one of these depending on whether or not these are true, and it will only execute one. Meaning if it turns out that like 3 of them are true, okay, in like a slightly different example, 3 are true, it just executes the first one that it finds to be true. So if I said, I don't know, true or, this, and then, actually that's a bad example, I'm not going to talk about that. Does that answer your question? Okay. Other questions? How many people really understand the slide now? Okay, I'm seeing more hands, which is good. So, as I said, this is just a somewhat more compact way to use the if-else. And going back to that fancy slide with that nifty animation, that's all it is. It's just sort of changing white space so it makes it a bit more convenient to read a series of if-else statements. So the last thing I want to talk about before we get to what's called a switch statement is the question mark : notation. So consider this code. Here, z is going to hold the lesser of the 2 values x and y. So if x is less than y, z equals x. Otherwise, y is less than or equal to x, then z is equal to y. So I've left out the braces. Although I tell you, you should always use braces. I won't always use them just because I often don't have space on the slides. This is another way to go about doing the exact same thing. What that says is z equals parentheses, x is less than y, question mark, x colon y. So what happens is you'll notice, first of all, that the Boolean condition is still there. We're assigning it to z. In either case, whether x is less or y is less, we're going to assign it to z. If the Boolean condition is true, we're going to assign to z the value x. If the Boolean condition is false, we're going to assign to z the value y. What this says here, this first one, if x is less than y, then z equals x. Otherwise, z equals y. Well, this says something pretty similar. I'm going to see if x is less than y is true. If so, I'm going to assign it x. If not, I'm going to assign it y. So this is just a slightly more compact way to do that sort of if statement. This doesn't work for all if statements, and we're going to see some examples when it does work and when it doesn't work. But it will work for some if statements. In particular, if you're assigning some variable z, a value depending on some Boolean condition. So here we're assigning to z either x or y, depending on the yellowed Boolean condition. Then the the question mark colon notation would actually work well. So the thing is that it only works well when the cases return values. What I mean by the cases, and it's probably a bad terminology, you'll notice that so obviously Java, when it's going through this, it's either going to use the value in x or the value in y. But both of those are values, right? They're both, let's pretend they're integers. It's not a print statement. A print statement doesn't give you a value. So it only works when both cases actually give you a value. Z is equal to x or z is equal to y. Java's going to do one of those two things. Right? Z is equal to x or z is equal to y. Which one it actually uses is dependent upon that Boolean condition. Is x less than y?
So if we wanted to assign the value to z, and then we wanted to print, z is going to equal x and then print out, z, if we wanted to do both those things in our if statement, then, we can't do it using z.
Correct. So the question is that in addition to, I'm going to go back slides to explain this. If you wanted to do here, in addition to assign a value to z, also print out something, then yes, you should probably use an if statement with braces. If all you want to do is just assign a value, and maybe have a print after it or something, then you can use the colon question mark notation.
If you want, I know that will work using integer value for either x or y. But if you add x as a double and y as an integer, would it still work?
The question is, if they weren't all ints, what would happen? Like if x was a double, y was an int, that sort of stuff. So as it turns out, Java can compare a double and an integer. 3 is going to be less than 3.5. Java has some problems assigning values. Like you can't assign 3.5 to an int because there's the 0.5 Java doesn't know what to do with. You can assign an int to a double. So I would say the quick answer is we will normally be seeing this only with the same type. Yes, you can mix types with some restrictions. I'm going to sort of ignore the restrictions for a bit. Okay, other questions on this? Yes?
Would we need to initialize any of those variables? Would we need to say at the beginning, int z, and then say what z is going to be equal to depending on something?
So the question was about variable initialization. I'm assuming at this point, at this point in the code, I've assumed that x and y are initialized to some values. Whereas this is actually giving z a value. So maybe z has a value before, but one way or the other, at the end of this code, z will have a value. So x and y should have a value there, but z doesn't necessarily have to have one.
But z is already declared before then?
You have to initialize it first.
Yeah. Oh, that projector just went out. Yeah. I didn't touch it this time. Yeah, I will. I want to see if the projector is going to boot up again. Does anybody see any light coming out of it? So I think that the bulb in that is like $10,000 or something. Well, it's not my fault. I hope they don't charge me. All right, give me 2 seconds. I want to tell the technical people, and then I'll start using the chalkboard. Oh, don't try to hide your disappointment here. It just spontaneously went out.
Well, I mean, it was just a
No. So I don't know if I'm going to reset. Okay. But it just went right in the middle. I didn't touch anything, and it just went out. I was 10 feet away. It wasn't my fault. Okay. So the problem with this colon question mark notation is it sometimes can be very difficult to read. Remember that we had the example if n is equal to 0, then print out 0, else if n is equal to greater than 0, print out positive, else if n is less than 0, print out negative. That ends up being a bit more difficult. If you wanted to do it, oh, this is going to just take forever for me to write on the board. So we could say if n is equal to 0, print out 0. Else, if n is greater than 0, print out positive. Else, print out negative. Right? And you'll notice here that this colon mark question notation, yeah, I know, you're so disappointed. This colon mark question notation is embedded in that one. It ends up being very difficult in terms of trying to understand what the heck is going on. So this is sometimes good for sort of a quick way to compress code. It's often not very good if you have something more complicated or you have if-else. Okay, should we do a countdown? 3, 2, 1. So what did you Oh. Okay. Thank you. See, all of you doubters, modern technology and extremely helpful technical staff. Actually, they have, obviously everyone's heard of ITC. The really big classrooms in the universities, such as this one, actually have specific people who work for ITC who are, their office is right next door in case something happens. Because, again, I wouldn't want you all to be disappointed that I had to say, end lecture early. Okay, so as you see, right, we could put a colon question mark notation inside it. It's really difficult to see what's going on. So there are times that this is good and times that it's bad. Oops. Questions or comments? Okay, so this is, I'll read through the text because it's probably hard to read from the back row, but this is sort of a joke on computer specification. So this is how the customer explained it. The customer wanted a swing, although it kind of explained it wrong. This is how the project leader understood it. This is how the analyst designed it. How the programmer wrote it. How the business consultant described it. Notice the rays of light shooting out from behind the chair. How the project was documented. See comments. What operations installed. How the customer was billed. How it was supported. And this is what the customer really wanted. And for those of you going on in the computer, within computer science, you're going to start studying software engineering practices more so than we'll see in this course. In fact, there are whole upper division courses on it. And it's scary how much of this is often true. Okay. We've seen 3 of the 4. If else, and if else if. Last up is the switch statement. So, just like the if and the if else, any code with all of these things will either be executed 0 times or 1 time. On an if else, then what's in the if, let's say the condition is true, what's in the if is executed once and the else is executed 0 times. Well, the switch statement is something pretty similar. In particular, if you are dealing with integer expressions, you can often use a switch statement. Right. I'm going to ignore that. Consider this code. We are dealing with a character variable A, that has been initialized to some value. I'll assume it's 0, 1, it's some digit. So if A is equal to the digit 0, I'm going to print out 0. Else if A is equal to 1, print out 1, etc., etc. And here we have a long if-else if chain that basically will print out a string, 0, 1, 2, 3, 4, or 5 plus, depending on the value of the character variable A. And this is, it's very similar code to what we saw before. But obviously does something slightly different. The thing that is, this ends up being useful in some contexts, but also even if-else if can be somewhat hard to read. And if you have a long chain of these, and I've had, some of my programs have had, literally dozens, it becomes a bit of a pain to actually have to sit there and do each if-else if. And also, if the character variable A is the digit 5, it's going to have to test that, and that, and that, and that, and that, and keep going down. So, Java, well actually many other programming languages, but they came up with something called the switch statement, which looks like that. Both of these code segments do the exact same thing. They will print out 0, 1, 2, 3, 4, or 5 plus, depending on the value in the character variable A. So, a couple things to note. Here we have the same thing to do, right? All the print statements. But the one on the right says switch on A, meaning evaluate what A is. A can be an integer or a character expression. It can be a variable. It can be, an addition, equation, whatever you want. You need to evaluate to a character or integer value. And then what this says is, if A is equal to the character 0, I'm going to do this. We'll get to the break in a second. If A is equal to the character 2, I'm going to do that. If it's equal to 4, I'm going to do that. Notice that the case, so on the left, the case says if A double equals 1, meaning if A is the same value as 1. On the right, we just say case 1 and a colon. The quotes are around the digits because we're talking about characters. If we're talking about integers, we wouldn't have those quotes around them. Okay, some more things to note. We have a default. That's basically like an else. That says, so what happens is when Java's going through this, it's going to look at the value in A and match it to one and only one case statement. If it matches to the case statement 1, it will print out 1. If it doesn't match to any of these, it goes to the default thing. We don't have to have a default there. Just like we don't have to have an else here. I could sit here and scribble out, I could try to scribble out all of that. But that's essentially what the default is it's like an else. The other thing to note is the break. We're going to see breaks a bit more when we start getting into loops, which I guess we'll start talking about probably Friday. But what happens is that when Java sees the switch statement, it's going to jump to the particular line that matches that case. So if A is equal to the character 3, it's going to jump to that line. And what happens is that Java will start executing the code from that line until it hits the closed bracket that you can't see off the bottom of your screen. Meaning it will execute every bit of code between them. So if we didn't have, and what the break does, it says, I'm finished, you can continue. But if we were to take out the break statements, and now the character A was 3, it would print out 3, 4, and 5 plus. Because what happens is Java jumps to here and executes every line until it hits the closed curly brace. Because we have the break statements in there, Java knows that once it finishes executing, I want to erase it, don't I? Once it finishes executing this particular block of, once it finishes executing that one thing, it hits the break. The break. No, it's not a sign. Once it hits a break, what it's going to do is it's going to jump to that closed curly brace. This will work, I promise you. Well, you know what? I think that I probably will have to cancel class early. Yeah, I know you're all disappointed. Please try to hide the disappointment. Hopefully the projector will work next time. You're applauding for me because I'm not teaching. I'll see you on Friday.
Watch the clock for you, nor doubt the bitterness of absent sour when you have bid your servant once adieu. Oh, nor dare I question with my jealous thought where you may be, or your affairs suppose, but like a sad slave, stay and think of naught but where you are, how happy you make those. So true a fool is love, that in your will, though you do anything, he thinks no ill.
I hope that you don't actually think of yourselves as slaves in this class, or me as a sovereign for that matter.